Alright everybody, welcome back to another video. This is the final lesson in the Godot 4 Golang MMO tutorial series, where we're going to be taking our game and we're going to be deploying it to the cloud so that all our friends can play along with us. So if you want to follow along, I suggest coming to tbat.me/projects, come and find this Godot 4 Golang series, and we're going to scroll right to the bottom to lesson number 12, deploy your project to the cloud. And I'm going to be following this blog post in this video. And if you want to download the source code for the end of the last video, you can just click this version 0.11 here. And that will take you to the GitHub release where you can download the source code zip. And that will be all the code you need to get started to follow along with this video. So this part's going to be broken into roughly two parts. In the first part, I'm going to be showing you how to deploy to Google Run Cloud, which is a pretty inexpensive pay-as-you-go cloud model. And there's currently a way to get the first 90 days for free, or I believe the first few $100s for free, whichever one sort of expires first. So this is definitely a good option for testing things out and seeing if it's going to be a good fit. I think it's quite good. The other option is going to be self-hosting. So if you happen to have a computer that you can afford to leave running 24/7 at home, or if you have some sort of access to like a home server or something like that, you can even run this on a Raspberry Pi. This will be a good option for you, which will be covered in the latter half of this video. But the rough steps for sort of each is going to be looking at obtaining a SSL certificate for security, containerizing the application so that we can run it in Docker, and exporting the client to HTML5. In terms of hosting the client, we can look at two options as well. We can look at either itch.io or hosting it on your server, the same server that runs the game. So without further ado, let's go ahead and get started and continue watching from here if you want to go down the Google Run Cloud route. Otherwise, I'll leave some timestamps and chapters in the description, and you can skip to the self-hosting section. Alright, so the first change we're going to make in order to get our game into Google Run Cloud is we need to containerize our server so that we can run it in Docker. We'll be pushing our code to Docker Hub, and then we'll be pulling it from Google Run Cloud to spin up in an instance. So to make life easy for ourselves, we're going to come to the server code in the cmd and main.go. Instead of passing in the port as a command line flag, it's going to be a lot easier moving forward to start using environment variables, because this is going to be compatible with Docker and Google Run Cloud. And we're going to want to add a few more variables to pass into our program. So I'm going to create a file just under the root server directory. So not in cmd, but under root. And I'm going to call this .env. And this is going to be a convenient way for us to store our environment variables. So for now, we're just going to have one variable called port, and that will be equal to 8080. So I'll save my env file, come back to main.go, and I'm just going to remove this port, and I'm going to get rid of this flag import and the flag.pass. So we're going to have broken a few things, so I'm just going to save it anyway. What I want to do is get environment variable parsing into my project. Conveniently, there's a tool called go.env, and we're going to just install that. So I'm going to type cd server. So now I'm in my server directory, and I'm just going to go and type go get github.com/joho/go.env, which funnily enough looks exactly like Godot env, but it's actually pronounced go.env, as in .env. So anyway, we've acquired go.env now. What we can do is import that package in our main.go file. So github.com/joho go.env. And let's go ahead and create a config struct to store all of our config stuff inside. So we're going to make type config struct, and it's just going to contain a port number. Now let's just create a variable called default config, and this is going to be a config struct with a port of 8080. And we might as well actually allow the user to specify a path to their config file, just in case they don't want to have a .env file. They can actually supply a different name. So I guess we're going to bring the flags import back. This is going to be equal to flag.string, and the name of the flag is going to be config. The default value will be .env. So if you don't supply this flag, env will be chosen for you, and we'll just say path to the config file. So this will be like the helper text. Now I'm going to make a function to load our config and populate our struct. So we'll call it load config. It will return a pointer to a config struct. So we'll just assume that the config we want to return is just going to be the default config that we specified up here. And then what we can do is check if the port exists in our environment variables. So we're going to import the string conversion a to I. So this will turn a string into an integer. And we're going to use os.getEnv port. So after we load our environment variables via our config file, we can get those variables with os.getEnv. So we will check if error is not nil, log.printf error parsing port using default value. And in this case, we will just return the default config as well. And I suppose we can actually just call this cfg.port. Right. Otherwise, we can just set the config's port to the port that we grabbed from the environment variables, and we will return the config that we constructed. So this will basically just try to load a port from the environment variables, and if it fails, it'll just return the default one. So now let's actually load the environment variables. So first we're going to run flag.parse. This will get our config path that we can optionally supply. So we can use that. So error equals go.env.load, and we'll give it the config path. And then we'll try to grab the config. Load config. Well, I guess we should only load the config if there was no error here. So let's first check. If error is not nil, log.printf error loading config file defaulting to default config. Else we can use the load config. So I guess we'll set config equals to default config to begin with. And then if there's no error loading the environment variables, we'll set config equal to load config. So now we have our config struct, and we can use that in place of this port. So we can use cfg.port. And I'm just getting an error here because it looks like I'm trying to redeclare the error variable. So I'll just remove this colon. So this is clear that we're just reassigning the value of error. And now we've set ourselves up to use a config struct that we can load from environment variables. So I should be able to save the server code and rerun it. And you can see it says error loading config file defaulting to port 8080. So let's see why that would be. Yeah, so when I use the debugger, I'm not actually supplying. Yeah, so we're starting the debugger from this directory, which is the CMD directory, but our .env file exists outside the CMD directory. So what we can do is I'll stop the server. We can modify our launch.json file, and we can actually specify the current working directory. And we can set that to workspace folder /server without the /cmd. So if I try that again, we should see, yeah, no problems grabbing the env file there. So if I actually set this to 8081 and rerun the server, we should see starting server on port 8081. So the environment variable seems to be working. We can even be more explicit about it if we want to, and we can set the args in launch.json to supply the config flag directly. So --config and then workspace folder server.env. So that way we don't even need to be setting this current working directory if we supply the argument explicitly like this. As you can see, it still says 8081, but why not just supply both, I suppose? It doesn't hurt. So now what we can do is we can actually supply a path to a data directory. So we can actually tell the server where to put the database, which is going to be really convenient for us moving forward. So let's create a new environment variable called data_path, and we can just set that equal to, well, we can set that equal to anywhere we like on our computer. So I'm going to make a new folder on my desktop called radius rumble data. And this is important because when we containerize our server, we don't want to be storing the database inside the container, because as soon as the container is stopped or the container needs to be rebuilt, we'll lose our data forever. So it's important to store the database outside of the container, and that will be just somewhere else on the server. Or in the case of Google Run Cloud, that will be in an online storage bucket. So to simulate that just on my computer, I'm going to make a new folder called radius rumble data. I'm going to copy the path to that, and I'm just going to paste it here. So now in my main.go, I can try to load the data path config variable. So in my load config function, I'm going to try to grab the data path. The data path equals os.getEnv data path. And I'm going to add a data path member to my struct, which will be a string. And then I'm just going to set my configs. So cfg.datapath equals data path. And I guess I could simplify it by just doing it like this. So I'll just load the default config and then immediately set its data path to obtain from the environment variables. So we want to pass the data path into our new hub function so that it can use that to know where to create the database. So I'm going to pass cfg.datapath into the new hub function, and then I'll need to come to the new hub function and make it accept a data directory path, and that will be a string. And then instead of just creating this db.sqlite file here in the cmd directory, we're going to use path.join data directory path and db.sqlite. So all of the errors have disappeared now. And if I run my game, it should create the database in my new Radius Rumble data folder, as you can see here. So that's all good, but it would be nice if we could try to create the data path in the specified location. And if it couldn't find that location, it will have like some sort of fallbacks. And it would be nice to cycle through a few different kinds of fallbacks before it eventually gives up. So for that, I'm going to create a new function called coalesce paths. And I'll give it a list of strings called fallbacks, and it will return a string. So basically this function is going to try to find the first fallback directory, and if it can't find it, it'll use the second one, and if it can't find that, it'll use the third one, so and so until it arrives at the final fallback. If it still can't find that, it's going to print an error. So we'll do for I and path in range fallbacks. We're going to check if the path exists. So if error equals os.stat path, and we're checking if os.isNotExist on the error. So this is just saying if the path doesn't exist, then we'll make a message that says file/folder not found at location, and we'll check if I is less than the length of the fallbacks, -1. Then we can move on and try the next fallback. So log.printf will print the message, and then going to try, and then we'll get the next fallback. So fallbacks I+1. Otherwise, if we are on the final fallback, then I'll just log.printf error message, and then no more fallbacks to try. In the case that the path does exist, we're going to print file/folder found at location and return the path. And if we get all the way to the end and we've hit the no fallbacks to try message, we're just going to return an empty string. So what we can do now is in our main function, when we load the config, we can reset the data path to coalesce, and these are going to be some of the fallbacks. So obviously it's going to try the data path first, but if that wasn't found, it's going to default to the current directory, which we can specify with just a dot. If I change my data path to a folder that doesn't exist, like 123, and I'm actually just going to delete my old database file, just so it doesn't confuse us, and I'll rerun the game. It should say file not found at radius rumble data 123, going to try dot, so that's the current directory. And because we set the current directory to the server folder, it's going to say file found at dot, which means file found at the server folder, and it's gone ahead and created that database file right there. So our coalesce paths is working. I'm just going to delete that database, and I'm going to change my environment variable back to just radius rumble data. And one of the advantages of doing this is we can set ourselves up early to be compatible with Docker. So I'm going to make a constant called Docker mounted data directory, and I'm just going to set this equal to game server/data. So this is where, when we eventually create a Docker config file, we're going to make sure that we mount our data at this location inside the container. So if the server is running in a Docker container, the data directory is always mounted at this path. So now what we can do is we can add that to one of our fallbacks. So if we don't supply a data path, we'll just try the Docker mounted data directory. This is how we're going to easily store our database outside the Docker container, because eventually we're going to mount the game server/data folder outside of the container. So that will exist somewhere else. So that will become more clear later. And for now, I'm just going to leave a comment here as well to say, try to load the Docker mounted data directory. If that fails, fall back to the current directory. So obviously, if you've changed your port in the environment variable, just make sure to change it on the Godot side of things inside the entered state. So in entered.gd, you'll just want to update this port value here. All right, so let's actually work on containerizing our server. So to start, you'll need to install Docker. So I'll come to the Docker website. There's a section called Get Docker, and I'm just going to choose the option that applies to me, and I'll just follow the instructions to install Docker. All right, and now that that's done, I'm going to try to see if I have it installed by typing Docker, and you can see I'm getting an error. So I just need to restart VS Code. So I'll be back in a sec. So now if I type Docker, I can see the help file here. So that's all good. Now I'm going to create a Docker file, which is going to tell Docker how to exactly build our server. So that's going to include things like installing Go, installing all of the dependencies, and then the commands that we need to use to run our server. So I'll come to just the server folder, create a new file called Docker file with a capital D. And here we're just going to say from Golang :1.23, or just use whichever version you have in your go.mod. So I've got 1.23, so I'm going to use that in my Docker file. And then we're going to say the working directory is going to be /user/source/game server. We're going to copy our go.mod and our go.sum files to the working directory. So that's these two files we're going to copy. And these will be used in our container to actually build our game. So then we're going to use run go mod. So go mod will just install all of our dependencies. So go mod download and go mod verify. So that's just going to verify all of our packages. And then we're going to copy the source code. So we'll type copy from our local server folder to the Docker working directory. And then we'll run go build -v-o. So the -v flag will just make everything print to the screen, and the -o flag is the output. So we're going to say /game server/main, and this will be the name of our binary executable. And what do we want to run? So we'll do ./cmd/main.go, and then we can actually run our game. So we'll type cmd/game server/main. That's our executable. And we can pass in a config of .n. So the preferred way to run a Docker container is to create a compose.yaml file. So I'm going to create a new file as well, and I'll call it compose.yaml. And this is going to tell Docker exactly how to spin up the container and all of the accessories that are going to go with it. So I'll type services, although we're just going to have one called game server. We're going to tell it how to build this thing. So we'll type context.docker file is our Docker file. We're going to tell it the environment file is going to be located at .n, and we're going to tell it the volumes can be obtained from data path, which is going to be an environment variable that we've loaded this way. And we're going to mount that at game server/data. So basically, this means that when we spin up our container, it's going to mount whatever I put in here to the /game server/data directory, which conveniently is what we've hard coded to be where we look for our database. And we're also just going to say ports is going to be from our environment variable as well. So now if we type docker compose up, but we need to be in our server directory first, so cd server and then docker compose up. It's saying that there was a error on line 11, found unexpected end of stream. Oh, so I've got two quotes here. I just need one quote. All right, error during connect. And I think it's just saying I need to run Docker as an administrator for some reason. So let me, actually, I think, yeah, probably I need to actually start Docker. That would help. So I need to open up Docker, and yep, I'll just accept the agreement. I'm just gonna, well, actually this might be useful for later. I am actually going to sign in, and I'm just going to click the sign in with Google. And this should prompt you to create an account as well, or you can use this create account button. I'm just going to skip the survey. Okay, so now I actually have an account with Docker, which is going to be convenient for when we push to Docker Hub. So yeah, I just recommend making an account at this stage if they ask you to. So now that I have Docker running, I should be able to try running docker compose up again. And that's going to use this compose YAML file to start running my Docker file, which tells it exactly how to install my dependencies for my game. And then it's going to go ahead and do all of the accessories that come with it. So it's going to load the environments, it's going to mount my data directory, and it's going to know which port to expose as well. So I'll just wait for all of these things to download and install. And it's just giving me a little security warning saying it wants to access my data directory. So I'll just click yes when it asks me if I want to share it. And for some reason I get another error, so maybe I'll just try that again. Yeah, I think maybe I took too long to click yes or something. So if you see an error, maybe just try again. But you can see now it says, so yeah, you can see like this is now running inside the container. So when it reads my env file and it tries to literally interpret this path, but because it's running in like a Linux container, it's not going to find this path because this path exists on my Windows machine. So then it says it's going to try /gameserver/data. And it says it does find a file there because that's what we've told Docker to mount my path to. So if you do see not found, don't worry, it's not an error. It's just saying we're not running on Windows anymore. We're now running inside the container. So this is why we do this. This is why we do this volume mount. So it says starting server on port 8081. So I'm just going to try to make sure that my Godot entered state script matches that port. And then I'm going to try connecting to it. And you can see it has no problem connecting to it, even once it's running inside the container. So let me just see if I can create an account. And you can see there are errors being outputted to the container, so that's a good sign as well. And there we go. We can see that it is indeed using the database file here, because we don't see any database file anywhere here in our server folder. All right, so the next step is to actually push this container to Docker Hub. So I'm going to close this and I'm just going to press Control-C in this terminal and that will stop the container. And by the way, next time you want to run, if you want to run it in the background, you can type docker compose up -d and that will run the container in the background. And if you want to stop it, you can just type docker compose down and that will stop the container from running. So the next part is to get this into Docker Hub because we need to host our container somewhere online so that Google Run Cloud can go and grab it. So we're not going to be uploading our Docker directly to Google Cloud. We're going to be using Docker Hub as an intermediary. So we have our Docker Hub account. If not, you can come to Docker Hub, click sign up. And I just like to click continue with Google, but you can sign up however you like. And once you have your account, you can come to your profile and you can grab your username from the URL here, or just, this is the username as well. So I'm going to copy my username and type, so I'm going to make sure I'm in my server directory and I'll type docker tag server-game server latest. And then I'm going to type my username, paste my username there, /game server :latest. So just make sure that this is your Docker Hub username. And now if I press enter, there should be no issues. So this is because I'm logged into Docker desktop as well with the same account. So now I can type docker push my username /game server :latest. And that's going to try to push everything to Docker Hub. So it's just uploading the entire image so that it'll exist out there in Docker Hub and it can be easily pulled by anyone or any service. And if you get an error, you can just come to your terminal and type docker login and that will ask you to log in with Docker Hub. But I'm already logged in, so there's no need. So you'll just need to wait for this to finish. And once that's done, if we just open up Docker Hub again and load our profile, we should see our game server in our repositories. So this has been successfully uploaded to Docker Hub, and just keep in mind that this is public, so don't upload any sensitive information here. This needs to be public in order for Google Run Cloud to pull from it, but I'm sure if you search up how to pull from a private Docker Hub repository, you should be able to make this private and figure out the next steps on your own. So finally, let's get our server deployed to Google Run Cloud. So I'm going to open the Google Cloud Platform website. And if you're not signed in with a Google account, just make sure you sign in. And there should be a button called Get Started or something like that. In my case, I have a button called Console up here. So I'm going to click that. And it's just asking me to create a project. So I will create a new project. And I'm going to call it Radius Rumble, but you can call it the name of your game, and you can just leave the organization blank, click create. Now that the project is created, we can select the project, or you can select it from this drop down here. So before we get started, we're going to need a place to store our database file, since we can't rely on the container storage being persistent. And so we're going to use a service called Google Cloud Storage. So if you just type here cloud storage, click on cloud storage. This will take us to a place where we can create buckets, which are kind of like online storage locations. So I'm going to click create bucket, and I'm going to call my bucket radius-rumble-data, and then just make sure that it says public access prevention is on. So this will just make sure that our bucket is private and nobody can access it from outside our account. And I'll just click on create. So it's just telling me this bucket is set to prevent exposure of data and just keep the setting enabled. So I'll just click confirm. So now that we have a place to store our data, let's come to Google Cloud Run, or just Cloud Run, and select Cloud Run from the search results there. So this is how we're actually going to be launching our containers. So on the services tab, I'm just going to scroll down and click create service. And this is now asking us the URL for the container image. So I'm just going to type docker.io/my Docker Hub username, which is saltytaro, and then game server latest. And I'll give my service a name of game server, and then just select the region that's closest to you, or the region that's closest to where you think your player base is going to be. So if you think all of your players are going to be running in US Central, then just select that. I suppose I'll find Australia, just because that's closest to me. And then I'm just going to scroll down to where it says containers, volumes, networking, and security. And I'm going to add my bucket as a volume. So I'll click this volumes tab, click add volume. For the type, just choose cloud storage bucket. Well, you can just leave the name as default. It doesn't really matter. And click browse, and we're going to find our bucket, Radius Rumble Data, and we'll select that. And just click done. And it's just saying the following volumes are not mounted to any container, so we need to go ahead and mount it. So we'll come back to the container tab. We're going to come to the volume mounts tab, click mount volume, and we're going to select our volume that we created. And for the mount path, we'll just choose game server/data. Now you can set the container port to the same one that you put in your env file. So I'm going to choose 8081. And we can just leave all of the rest of this stuff as default and click create. So it should only take a few minutes, and then our server should be back up and running. So once all of the spinning wheels stop and we have this green tick saying service is healthy, we can check the logs tab. And we should see file not found at this location, going to try game server/data, and it should say file/folder found at game server/data, and then starting server on port 8081. So what we can do is we can copy this URL, and this is going to be the location that our game server is running. So this is what we want to connect to in Godot. So let's open Godot, and in the enter.gd script, we want to replace this localhost port 8081 with our domain for our game server. So that's this part here. We'll just remove the HTTPS, and we're going to use the secure WebSocket scheme. So we'll use WSS://. So this should be the new URL we're connecting to. And just note that we're not using port 8081 anymore. We're actually using the regular HTTPS port, which is 443, but we can just omit that because it's implied. So Google Run Cloud will actually accept HTTPS traffic, which is secured, and it will route that to our app over port 8081. So it handles all of that for us, so we don't need to even worry about HTTPS certificates or anything like that. Everything will be encrypted and everything is served easily for us. So I'm just going to need a way to tell the connect to URL function that we're using TLS now. So I'm going to add an extra parameter called TLS options, which will be a TLS options. And I'm just going to get rid of this global variable up here. We don't need that. And we can see here we're using connect to URL with the TLS options that used to be the global one, but now it's going to be the one that we supplied to the connect to URL function. So now I can come back to enter.gd and pass in a TLS options. So I'm going to use TLS options.client. So if I run the game now, we see that we've connected successfully. And it took a second, but I think it's just because the container was just starting up, so it's a little cold. But once it warms up, it's pretty quick. So I should be able to create an account. You can see it says registration successful. So it takes a little while when we create a new account. So let me try to create another one. Yeah, so it's a little bit slow. So what you might want to do is disable the buttons while it's doing this, just because if you click the confirm button twice, it can break things. But basically the reason it's kind of slow when it creates a new user is because of the way that the cloud bucket works. So you can see here it says storage fuse will be mounted to an internal path. And basically fuse is a Google file system, which can work in a cloud bucket. And unfortunately, Fuse does not support concurrent writes or partial writes. So it's actually not a good choice to be running a database SQLite 3 file inside a Google Cloud Storage Fuse volume, because what it means is that every time you write to the database, it actually just goes ahead and uploads the entire database again and overwrites the existing one. So that's why there's a bit of lag when you register for an account. What you can do instead is look at hosting a SQL server within Google. So there's a SQL solution, a managed SQL server or a MySQL server. You could look at running one of these. The only difference is that it's a little bit more expensive. So this is just the cheapest and easiest option to get our game into the cloud if you're willing to wait a couple seconds when you register. But reading is fast, it's just writing is a little bit slow. So if I try to log in, I should be able to log in pretty much instantly, and I can still play the game as I normally would. So it's just the database operations which are a little bit slow particularly when you're uploading. But if I did connect with another account, I forgot the name of my account, fail to register. Okay, there I am. You can see that the game, like the packets that it exchanges, so the operations that don't occur within a database, are still fast. So there's no issues here when we're actually in the game. It's just sort of like the database operations with the SQLite 3 and the Fuse volume that can be a bit slow. But you can see here that there's pretty much no latency. It feels pretty much exactly like it did when I was developing this locally. So now we're officially playing our game from a cloud location, and we're one step closer towards letting our friends play with us. So next we need to focus on actually hosting the game client, and we can use itch.io for that. So let's first try to get the export templates. So I'm going to come to Project, Exports, and I want to export to the web, so I'll choose Add Web. And if you get an error saying that no export templates have been found, then you can just click on Manage Export Templates. And because we're using a preview version of Godot 4.4 Dev 3, it's saying that we need to install our templates from a file. But if you're on the stable release, there should be a button here that says download and install. So I'm just going to go ahead and download the export templates for Godot Dev 3. So I'm going to come to the Godot website. I'm going to click on the experimental releases section, come to 4.4 Dev 3, or whichever release you're working with. At the time that I'm recording, 4.4 Dev 3 is the highest version that actually works, because there is currently a bug, which hopefully will get fixed soon. But the bug affects 4.4 Dev 4 onwards. So that's why I'm going to be clicking on 4.4 Dev 3. And then I'll just scroll down to where it says export templates, and I'll download the standard ones. All right, now that that's finished downloading, I can click install from file, and it's already looking at my downloads folder. So it's found that it's got a export templates.tpz file here. I'll just open that. And now that's all done. So I can actually click close, come back to project, export, and now I don't have any errors down here. So I'm just going to leave all of this as it is, except I'm just going to enable the experimental virtual keyboard, which will allow mobile users to type. And then I'm just going to click export project. I'll make sure this export with debug button is unchecked, so there should be no debug, and just name your file index. So it should say index.html. I'm going to store it inside a new folder in my Radius Rumble data file. So the Radius Rumble data file that I created where we're storing our database, I'm going to create a new folder inside there called export, or you can call it whatever you like. And you don't have to save it here. You can also save it wherever you like, but for me, this is going to be the most convenient for later on in the video when I'm talking about self-hosting. So I will make sure I'm inside my export folder. I've got index.html and I've got this export with debug option unticked, and I'll click save. So if I open up my Radius Rumble data folder, I should have an export folder with all of this stuff in it now. And this is what we'll be uploading to itch.io. There's also a new button now. Up here, you can click this remote debug button and click run in browser. And this will allow you to debug the browser build of your game. So it'll open up my browser window, and it's still connecting to my Google Run Cloud server. So it's good to see that that's working in the browser. So now I'm going to come to itch.io, which is a free game distribution platform. And if you don't have an account, you can register for one. I already have an account, so I'm just going to log in. And then in the dashboard, just click create new project. You can give it a name. So I'll just call it Radius Rumble. You can give it a project URL. So this is just something that goes at the end of your itch.io profile. So I'll call mine Radius Rumble. And then for the kind of project, just select HTML. So it says we need to upload a zip file. So I'm going to come back to my exports folder, and I'm actually just going to right click on it and click compress to zip file. So I've got an export.zip now. You can choose a release status, and for the uploads, just click upload files, Radius Rumble data, export, or export.zip. And just make sure you tick this file will be played in the browser. You can choose your viewport dimensions. So it's probably a good idea to choose what appears in the project settings, window, viewport width and height. It's probably a good idea to choose some scaled down version of that. So instead of 1152, let's see, what is half of 1152? That's 576. So let's go with that for my width. And the height was 648. So half of that is going to be 324. These are all optional, and you can fill out the details, the genre, and all of that. And then once you're ready, you can click save and view page. So this uploads your zip file, and you should be able to run the game. And here we are. So now we're playing our game, which is hosted in Google Run Cloud, and we're playing it on itch.io. So you can see it's still in draft. So if you just click this draft button here, click public and click save, that will publish the game, and you can click this view page button. Now this is the URL that you can grab, and you can send this to your friends. And by the way, if you don't want to have to click the button to run the game, you can come back to edit game, scroll down to automatically start on page load, and you can just tick that. View the page again, and you can see it just automatically loads. So if you give this URL to your friends, they should be able to jump in and play along with you right from their browser. So they don't need to download the game or anything like that. They can just play. There's lots of other options you can mess around with. Like you can play around with the width and the height. You can create a full screen button, which appears down here. And now I can play in full screen. So this is fully cross-platform too. So if someone wants to play from their desktop version of the game, what you can do is you can export to Windows, and you can make an executable. So now if I have this version on my Windows machine, instead of playing in the browser, I can come and log in as well. And you can see I can play with the player who's playing from their browser. So that's pretty cool that we just get cross-platform play for free, basically, with the Godot export templates. Congratulations, you can share the link with your friends and you can play all together now. So if you've made it this far, you're finally at the end. You've deployed your game to the cloud, you've exported your client to a distribution platform, and you can finally play with your friends. We've learned a great deal together, and I hope that you've enjoyed the journey as much as I have. And if you want to learn how to serve this from your own computer, or serve it from a server that you own, stick around for the next part of the video where I'll be explaining how to do that. So we can avoid using Google Run Cloud, and instead we can just roll our own server. But if you are happy with how this is now, you can stop watching the video from here, and I hope that you will join us on the Discord server to share your progress. And if you need any help at all, don't hesitate to reach out. If this series has helped you out, please leave a like on the video and consider subscribing to the channel. So you've decided to host your own game server at home, or if you have a virtual private server somewhere else. How is that going to work? What are the differences between this and using Google Run Cloud? Well, we're going to need to provision our own TLS certificate, and for that we're also going to need our own domain name. So I'm going to assume that you have a Linux server and your own domain, which you can register if you just search how to register a domain. And the process for pointing your new domain name at your server should be pretty similar, so I'll roughly go through that step. But to make life easier, while we're developing, we can trick our computer into thinking that our domain is already set up, and we can issue a self-signed certificate just to test things locally before we take the plunge and set things up on the server. So if you're on Windows, you can open up Notepad as an administrator, go File, Open, and then just come to C/Windows/System32/drivers/etc. Choose all files, and then just open up hosts. This is kind of like where you can configure fake DNS records on your own computer. So what you can do, you can type the IP address on the left-hand side. So for your personal computer, it will be 127.0.0.1, and then a space, and then you type what you want your development domain to be. So I'll choose dev.radius.rumble.tbat.me. So go ahead and save that, and then you can close Notepad. And if you're on Mac or Linux, you'll want to just edit the file that's located here, etc/hosts, and the syntax will be the same. And now we just need to generate our own self-signed certificate. So we're going to use a tool called mkcert, and you can come to the releases section on the GitHub repository. There'll be a link in the description and in my blog post. And we're just going to download the release for Windows AMD 64. But if you're on Linux or Mac, you'd be better off following the instructions in the README. So these are some instructions for Mac, and then these are some instructions for Linux. But for Windows users, just download this AMD 64 release and go to where you've downloaded it. You'll want to copy this executable, and we want to place it somewhere on our path. So I'm going to come into local app data, and I'm just going to make a new folder. And I'll just name the folder mkcert, and I'll paste the executable in there. And now I'm just going to add this path to my system path. So I'll type edit the system environment variables, click on environment variables, double click on path, new, and just paste that like that. So now if I restart my terminal, I should be able to type mkcert-install. And it's still not recognized for some reason. I need to rename my binary executable. So I'll come back to local app data /mkcert, and I'm just going to rename this to simply mkcert without all the extra stuff. So now if I reopen my terminal and type mkcert-install, it's just going to give me a warning about installing a self-signed certificate, but I'll just click yes. And now it says my local certificate authority is installed in the System Trust store. So now what I can do is make a specific certificate for my fake domain. So I'll go dev.radiusrumble.tbat.me. And now it's saying that it's created some new certificates. So if I have a look, I can see my two certificates are just here where I ran the command. So that's just in my C users Saltitaro folder. So I'm going to open up this folder, copy these two certificates, and I'm going to paste them in my Radius Rumble data folder that I have on my desktop. So if you don't have a place to put all of your data, just make a new folder anywhere you like and paste these two certificates inside. So we can use these, this is a public and private key pair, and we can use these when we're setting up TLS on our server. So we're going to have to use secure WebSockets on our server. So we'll come into the server code, and if you didn't follow along with the first half of this video, this file will look a little bit different to you. But basically, we've reconfigured things to accept a environment variable. So we have this .env file now, and this is what we're going to be using instead of passing in flags to our program. I've also modified my launch.json to include the path to this config file, and I'll put a There'll be a timestamp in the description for the part of the video that you can go and watch to reconfigure your server like this. But this is why I have this radius rumble data folder, and I'm keeping my database inside this folder instead of with the server code. So what we're going to do is we're going to add 2 new paths to our environment variables. One of them will be cert path, and this is where we're going to type the path to our public key. So I'm just going to select this and press Ctrl-Shift-C and then paste that here. So that will copy the whole path, and I'll do the same for key path. So now we've got our 2 paths for our certificates. And actually, just in case you do want to run your code in Docker on your server, it's going to be best to actually put these inside of a new folder and just call it certs. So these 2 guys are going to live inside a certs folder. This is just going to be because if you do want to run on Docker, which you don't have to, but if you do, we're going to mount this folder to a certs folder on the container. So since we're going to be giving Docker access to an entire folder, we want only the certificates to be in that folder. So I'm actually going to add my certs subfolder to my environment variables. And speaking of which, we can actually create a new constant in main.go. And this is optional, but I'm going to call it docker mounted certs directory, and we'll just mount this to game server /certs. So this is where our program is going to search for certificates if it cannot find any in our cert path and key path environment variables. So again, this is just convenient if you do want to run Docker on your server. I'll give you the option to do that. So let's add a cert path and a key path to our config struct. And then inside of our load config function, we're just going to set config.certPath equals get cert path, and key path will be getting the key path environment from the OS. So we're going to make a new function called resolve live certs path, and we'll give it a cert path parameter. This function is going to be really convenient for us if we are going to be using Let's Encrypt for the for provisioning the TLS certificates. Basically, it's just going to ensure that our we can run our server either with Docker or just on its own, and it's just going to be really convenient for us. I wouldn't worry too much beyond that. You can just copy and paste this script from my blog if you wish. But yeah, basically we're just going to be taking care of some of the path issues to do with supplying something in here versus where it actually might live if you have Let's Encrypt. So I'm just going to say normalized path is strings.replace all cert path with, so I'm just going to make this compatible on Windows. We're going to replace backslashes with forward slashes. And then I'm going to grab the path components, which will be strings.split normalized path on this /live/separator. So this is something that appears when you install Let's Encrypt. This is what appears in the path to your certificates. And then we'll say if the length of our path components is more than 2, then we're just going to get the tail end. So path tail is path components length of path components -1. And then we're just going to return coalesce path. Our first preference will be the cert path, and our second preference is going to be file path.join docker mounted certs directory with the live subfolder, and then our path tail. So basically it's going to try to search, it's going to try to prefer whatever we put in here first, but if it can't find that, it's basically going to look in game server /certs/live/this, which is most likely going to be where you've got your Let's Encrypt installed. And at the end of all of that, we're going to return the cert path. All that's to say we can load our certificates into our config. So config.certPath equals resolve live certs path using the config's cert path, and the same thing for the key path. And I might just move these 2 lines of code down here underneath where we start the server, and then I might add another log statement using cert at cert path and key at key path. And then we're going to try to listen and serve, but instead of using the regular listen and serve function, we're going to use listen and serve TLS. And this is where we pass in the address, but also the config's cert path and key path. and then we can check if the error was nil, we had some sort of error. So then let's try to start the server without TLS in that case. So I'm going to make this a regular printf instead of a fatal, because then we want to log something else. We'll say starting server without TLS, and then we'll say error is the old listen and serve without the TLS part. And then we can check again if the error is nil, and then this time we can log a fatal error. So if we save all of that, we should be able to run the game. And you can see it says using cert at my cert location and awaiting client registrations. So what I can do now is come to Godot, and you can see here that I'm already using a URL in my entered/entered.gd script. This is from the Google Run Cloud section. So I'm just going to get rid of this, and I'm going to type my fake domain, so dev.radiusrumble.tbat.me. And the second argument to the connect to URL function is just going to be TLS options.client, just to say that we want to use TLS and we are a client connecting to a server. And if you don't have the option to specify a second argument in here, I did type this function wrong back in the very first part. So there should be a second TLS options parameter here. And if there was a line up here somewhere that said TLS options equals null, just remove that line. If you copy and pasted from my blog post at the time, you will have the correct code, but if you were following along with the video, then you'll need to fix that up. So we'll come back to entered.gd, and this connect to URL function now looks correct. So I'm gonna go ahead and try to run the project. And I'm just stuck at connecting to server, so I'm just gonna make sure that my machine recognizes the fake domain. So I'll copy this, open up my terminal, and try pinging the domain. And you can see it does say reply from 127.0.0.1. I might just restart Godot and see if that helps. Actually, I just realized what the error is. So I'm trying to connect on the wrong port. So here I'm going to need to specify my port, which is going to be the same port in my .env config file. So I'm using a port here of 8081, and that's confirmed here where it says starting server on port 8081. So I just need to type 8081 here after the domain and before the /. And now if I run my game, I should be able to connect over TLS. So now you can see we are connected using secure WebSockets, and we can play the game just as before. And it's important to test the web export at this point as well. So I'm going to come to project, export, and I'll choose web. So if you don't have this preset here, you can go back to earlier in the video where I explain how to export to the web. I'll leave a little timestamp, and basically you just want to export to the web. And that will unlock this button here called remote debug, which you can click and run in browser. So if our browser can connect to our local server over TLS with our fake domain, then this pretty much confirms that we're going to be all good to go and deploy to our server. So this is really useful environment. It's important to be able to run your code over TLS even when you're working in dev, and you won't have any surprises when you try to deploy to production and things don't work. So that's just a little tip. But now as for actually deploying to our server, let's see if we can get that set up. So let's see if we can obtain a real TLS certificate for our server. So first of all, you're going to need a domain, and you're going to need to set up port forwarding on your router. So first things first, let's set up port forwarding. You're going to need to log into the admin interface of your router. And if you're not too sure how to get there, on Windows, you can type ipconfig, and you want to look for where it says default gateway. And then this will be the IP address of your router. If you're on Mac or Linux, you can type IP route and you'll search for something called the default route. So then you can come into your browser and paste the IP address of your router. And usually you can just press enter and it'll bring you to some sort of login page. I've customized the port on my router, so I'm just going to type that. And usually you can just Google the default username and password if you haven't changed it, or it could be physically printed on the back of your router. So go and check the back of the router for like a sticker that tells you your username and password. So I'm just going to log in, and there should be a button somewhere here called port forwarding. So mine is down here. I'm just going to click set up port forwarding. And these are all my ports that I've forwarded. I'm just going to click my add button. You should see a button called add, and mine will be different for yours, but you can just Google the make and model of your router, and there'll be some sort of instructions somewhere for how to forward a port. So I'm just going to fill this out for myself. So for the server IP address, or when it asks you for an IP address, what you want to do is give it the IP address of your server. So you should have a Linux server somewhere for this. I'm just going to SSH into mine. And once I'm in my server, I can type IPA, and this will show me my IP address. So under my network device, I'm just going to find my IP address here. So this is my IP that's local to my network. I'm just going to copy that. I'll use that for the IP address when I'm forwarding this port. And then for the port that we want to forward, just choose the same port that you have been using in your .env file. So I'll choose 8081 for the port start and the port end. And just make sure the protocol is TCP and click apply or click save. So now I can see an entry for my new port that I'm forwarding. So it's basically saying if someone visits my public IP address over port 8081, it will forward that request to this particular internal IP address. So that will hit my Linux machine. So now I'm just going to register a domain. So I am going to go with Namecheap, but you can go with whatever domain registrar you like. I'm just going to sign in, come to my dashboard. I'll come to advanced DNS. This will be different for each domain registrar, but basically if you know how to register a DNS record, this is what we're doing. And I'm just going to add a new domain record. I'll make it an A record. The host will be radius rumble, and the IP address is going to be my public IP address. So I can search what is my IP, come to whatismyip.com, and this will show you your public IP address. So just copy that, come back to your DNS records and paste that there. So we're going to have an A record pointing radius rumble at our public IP address, and just set the time to live, or the TTL, if you have the option, to 1 minute or the lowest possible setting. And that will just make sure that this change gets applied as soon as possible. So now if someone tries to visit radiusrumble.tbat.me, port 8081, that request is going to get sent straight to my Linux machine. So in order to grab a TLS certificate now, we should be able to install something called certbot, which is basically an agent for provisioning free Let's Encrypt certificates. So I'm just going to follow these instructions for how to install a package manager called snapd, because then we are going to be using snap to install the certbot. And that's going to be the most supported way to install certbot as of the time of recording this video. So I'm just going to find my, and by the way, you might actually have Snap pre-installed if you're using these flavors of Linux, but I'm using Debian. So I'm just going to come to where it says Debian and click on this, and I'm just going to run these commands. So now it's just saying I need to log out and log in again, so I'll do that. And now I should be able to get the latest version of snapd. So now I've got the latest version. What I can do now is type sudo snap install -- classic certbot. So this will install the, oh, I spelled classic wrong. This will install the certbot for Let's Encrypt certificates. Okay, so now that I have certbot, I'm just going to run sudo link -s /snap/bin/certbot/user/bin/certbot, and this will just make sure that certbot can be run. So if I type certbot now, I should get some sort of help message. Yep, so I'm getting something, so it means I've installed certbot correctly. So we won't worry about that just yet. Basically, because we're not actually hosting a website, the way that we obtain these certificates is going to be slightly different. What we need to do is go ahead and grab a script which is going to help us obtain a certificate just by DNS records. So I'm going to download this particular script from GitHub using wget. So this command will be on my blog post as well, just in lesson 12 here. This is the particular command that I've just copied, and I'm just going to run that command. So now if I look at what I've just downloaded, I've got a file called acme DNS auth, and just have a look at this file before you proceed and just make sure that you're happy with it. So it's just a Python file, and it's just doing some stuff to allow us to run to run the cert bot for DNS records. And we just need to mark this script as executable. So type chmod plus x acme-dns-auth.py. So now if we look at the script, it should be highlighted in a different color to specify that it is executable. And I just need to edit the first line of the script. So I'll type nano, which is a text editor, acme-dns-auth.py. And I'm just going to edit this first line here where it says Python. I just need to edit that so it says Python 3. You may not have to do this, but on most Linux distributions these days, the tool is called Python 3 rather than simply Python. So I'll just save that. And you can test this as well by typing Python. If it says command not found, then try Python 3. And you can type quit, open and close brackets to get out of this prompt. So if Python 3 works but Python doesn't, then you'll definitely need to edit that first line of this script. So now I'm just going to make a new folder using sudo mk directory at /etc/let's-encrypt. So that's let's encrypt, one word, and I'll create that folder. If it says that it already exists, then that's no big deal. And I'm just going to move my script into that folder. So sudo move acme-dns-auth.py to etc/let's-encrypt. So now if I list what's in that folder using ls etc/let's-encrypt, we should see it has my Python file in there. So now we can run the command to provision our certificate. Well, it's going to fail, but it's going to tell us at least what we need to do to get it to run. So I'm actually just going to copy this from my blog post because it's a bit of a long command, but it's just this one here that starts with cert bot cert only. And you're going to need to change to use your domain at the end of this command. So I'll just copy it and then we can edit it once we've pasted it into the terminal. And instead of yourdomain.com, I'll just use radiusrumble.tbat.me. So this is what I entered into my DNS records. So I'll press enter. And just for the email address, just enter your email address because it can send you renewal notices. Just say yes and yes, or you can choose to participate in this data collection. You can just choose yes or no. So now it says requesting a certificate. Please add the following CNAME record to your main DNS zone. So this is a DNS record that it's asking us to add. So we can come back to our DNS records. So I'll just open up Namecheap once again, come to advanced DNS, and I'll add a new record. It says it needs to be a CNAME record, so I'll just choose CNAME, and I'll come back and copy this. So this is the value. So the part before the CNAME, I'll copy this as the host, and I'll just get rid of the .tbat.me because that's my main root domain. So basically you will see your root domain at the end of this. So just copy everything before that part. And that's what the name section will be for your new DNS record. And the target or the value of this CNAME record is going to be everything after where it says CNAME. So I'll just copy all of this and just avoid the final dot at the end, although it probably won't matter. And this is going to be my value. So again, I'll just choose the lowest TTL possible of 1 minute, and I'll just click Save Changes. So you may need to wait a few minutes for this to propagate. You can check to see if it's propagated by searching your DNS record on a tool like MX Toolbox or DNS Checker. This is a free DNS propagation checker. So I can just type the name of my CNAME record dot my root domain. So basically I'm just going to search for this and just choose CNAME. Click search, and you can see it's already propagated to all of the regions and it has the correct value. So that means I should be good to try again, and I'll just press enter to continue. So that's going to recheck my DNS records. So now it says successfully received certificate saved at etsy let's encrypt /live/radiusrumble.tbat.me. So if I actually sudo list etsy let's encrypt live radiusrumble.tbat.me, I can see I have these files here. So the most convenient one for us is going to be this fullchain.pem. This is going to be our public key file, and privkey.pem is going to be our private key file. So we can use those in our environment variables or in our config file when we're telling our server to use TLS. So we've got our domain, we've got our port forwarding set up, we've got our certificates. We're now ready to copy all of our code to our server and start running it. And by the way, certbot will come with a cron job or a systemd timer or something that will automatically renew these certificates before they expire. So you shouldn't ever need to worry about these certificates expiring. If you want to be sure, you can run this command sudo certbot renew -- dry run. And this will just make sure that there's no issues with simulating a renewal of the certificate. So if this passes, you can be sure that you can basically just forget about this and let it do its thing. So for me, it says all simulated renewals succeeded. So I'm good to go. So I'm going to need to copy all of my server code to my Linux machine. So I can use the scp command to do that. I'm just going to need to move into my desktop /radius rumble. So this is my project directory. And here I have my server folder. So I can type scp-r to make sure that it's recursive. And the thing I want to copy is my server folder. So I'll type server. And then the place where I want to copy it to, I need to log in to my Debian server. So I'll type so this is my username and then this is the host of my Linux server. And then I need to type a colon. And then this is going to be the remote path you want to copy your code into. So I'm going to put mine just at my home directory. So /home/t, and I'll run this command. So that's just copied everything from my server folder into my home directory. So now if I list my home directory, I have a new folder called server. I'm just going to rename it to radius rumble server. And now I have this folder called radius rumble server. I can move into it. And here are all the same files as before. So I'll just want to modify the .env file. So I'll type nano.env and I'll just want to replace these values here. So for my data path, I'm just going to go with, I'll need to create this folder, but it'll be my home directory /radius rumble _data. And my cert path, I'm just going to type etsy let's encrypt /live /radius rumble.tbat.me /fullchain.pem. So this is the location of the public key. And for the key path, etsy let's encrypt /privkey.pem. So if I save this, and I'll need to remember to create my data folder. So I'll make sure I'm in my home directory and I'll make a new folder, radius rumble _data. So I've got my two folders now. Then I can move back into my server folder and I'll try to build my Go executable. So I'll type go build. Oh, and by the way, you'll need to have Go installed on this Linux machine as well. So you should be able to search up on how to do that. So I'll type go build -ld flags. We'll give it flags of S and W. So this should just make it compile without any debug symbols. So the code will be a bit faster. And our target is going to be cmd/main.go. So this is just downloading all the dependencies from my mod file. And when this is done, this should spit out an executable that I can just run. All right, so now I see I have a executable called main. So I can just run that /main, and I'll need to give the path to the config file, or it should actually automatically know to use the .env file. So I'll just call /main. But if you want, you can use config.env. And it says here, it's found my data folder. It's going to start the server on port 8081 as per my environment config. It's found the files or folders at my let's encrypt directory. And it's going to try to use these certificates, but it says failed to start server, cannot open because permission denied. So now it's just going to go ahead and try to start the server without TLS. So I'll press Ctrl+C to cancel that. So the issue here is that the etsy let's encrypt folder is protected. And instead of changing the permissions on this folder, which is not possible as far as I'm concerned, it's not really possible to change the permissions here and have everything run nicely without interrupting the certbot. What we can just do is run our game with elevated permissions. So I'll just type the word sudo before the /.main. And now there's no issues using those certificates. But if you are uncomfortable running your server as the root, what you can do is you can just copy these files into a different directory that you do have access to, and you'll have to change the environment config file to point to this new folder. And you'll need to change the permissions on the files themselves once they're inside the new folder. And you'll need to do this every 90 days, I believe. So every time the new certificate's renewed, you'll need to copy the files across again. So you can automate this using a script, which is what I would recommend. And I do have a script that does this that I went over in my first series. But I think that running this game server with elevated permissions is no problem because we know the source code, we're comfortable with everything that we've written, and this script isn't going to be doing anything nefarious. So it says awaiting client registrations, and we're serving over TLS, and we should be, with our port forwarding and of our domain and everything like that, we should actually be able to connect using Godot. So now instead of our dev environment, I'm going to type my actual domain. So radiusrumble.tbat.me. This is the domain that I registered, and I should be able to save that and press run. So you can see I've connected, and on my server log, it says new client connected from, and then this is just my local IP address. But this is just because I'm running from my same local machine. But if I connected from elsewhere, this would be the IP address of the person that connected. So I can still run the game same as before, although we have a fresh database, so I'll just need to register, and we can still play the game just as we could before. So now we have the game running on our own machine, but people are able to connect to it via our domain name, and we have TLS certificates encrypting all of the traffic for us. So I'll just make sure I can run this from my web browser as well, because that's usually the thing that's going to trip you up. This web browser has a lot more tighter security, but you can see here, there's no problems connecting whatsoever. So that's looking pretty good. So I'll just quickly show you, if I was to close my terminal at this point, it would actually stop the server. Or if I press Control-C to be able to type other commands, the server would no longer be running. So now the server has been shut down and I can't connect to it anymore. So how do you run the server in the background and make it so that even if you close the terminal, the server will still be running no matter what? So you can run the game server in the background by typing sudo nohup./main and then type an ampersand, and that will start your game running with this process ID in the background. So you can see it says ignoring input and appending output to nohup.out. So if I just press enter and check my nohup.out file, I can see everything looks good and it's awaiting client registrations. So I should be able to still connect, and there's no issues connecting here. So I can check my output once again, and you can see here that I connected, and it's just outputting everything to this nohup.out file. And the reason we use sudo here is just because we need to run our game as sudo in order to access our certificates. And even though it prints the process ID here when you run the nohup command, if you forget, you can always grab the process ID again by typing sudo ls of -i : and then type your port number that your game's running on. So for me, that's 8081. And it will tell me the process ID here again. So I can copy that. If I want to kill the server, I can just type sudo kill -9 and then type the process ID here, and that will stop the server. So I'll bring it up again. Sudo nohup./main ampersand. And by the way, if you wanted to pass in a custom configuration file, you could do --config and then your config file. Just put the ampersand at the end of the command. And now even if I close my terminal, as long as my server is still running, as in physically running, I should be able to still connect. So now our server is successfully running and people from the outside are able to connect to it, and we can just set and forget about it, especially if we have Let's Encrypt certificates auto-renewing. Just if you ever reboot the server, or if you have a power outage or something like that, you'll just need to remember to come back in and run that command to restart the server. Or you could even make a systemd service to make it auto start on boot, but I won't go into that here. So finally, we're just going to deploy our client. And in the first half of the video, I explained how to do that using itch.io. So you're free to follow along with that if that's what you want to do. But for me, I'm going to show you how to publish the client yourself using your own server again. So we can actually use the same server that we're using to run the game server to serve the client files. So I'm going to export my project, and I'm just going to make sure that I have the experimental virtual keyboard checked. And one more thing you can do, since we are hosting this ourselves, is you can enable thread support. So this is something that you can't do with itch.io because it requires a cross-origin isolated website, which is usually very difficult to set up if you don't own the server that you're running the client on. But in our case, we have full control, so we can afford to use threads in our game, which is a really nice reason to go with this option. So I'm just going to choose export all, and I'll choose release. And that will export it to my path that I've specified here. So before you do that, you could specify a path. I'm just going to export it to my desktop in my Radius Rumble data folder under /export. So I've exported my game. I'm now going to need to modify my server code a little bit. So I might as well add a new environment variable called client path. And I'll just set that equal to my Radius Rumble data folder /export. That's just this folder here. So I'm going to save that to a new config environment called client path. I'll come back to main.go. I'll add this new config to my struct. And I will add it in my load config function. And then I'll come down to the main function. And just before we define a handler for the WebSocket connections, let's define a handler for the client export serving. So we'll define the handler for serving the HTML5 export. And I'll say export path is going to be, and let's say coalesce paths config.client path. And if that fails, let's just search for it in, let's say, file path.join config.data path. And let's say the default is going to be HTML5. So basically, if it can't find it here, it's going to search for it in a folder called HTML5 in our data directory. So you'll have the option to either export here or export to a place of your choosing. It's really up to you, but we'll say if the export path exists, so we'll check if there's an error using stat on the export path, and we'll just check if the error is not nil. If it's not an issue where the folder doesn't exist, we will log a fatal message saying error checking for HTML5 export, and we'll just print the error. Else, if there was no error and this export path does exist, then we can do log.printf serving HTML5 export from location. And then we can create a new HTTP handler. So this is kind of like what we're doing here, but it's going to be a little bit different. So it'll be http.handle, and we're going to serve our game at the root path. So as opposed to /ws, this will just be /. And we're going to need to add cross-origin isolation headers to serve this as per what Godot mentioned. So we're actually going to, this function doesn't exist yet, but we're going to reference an add headers function. And we're going to supply http.strip prefix, and we'll strip the / from the http.file server with the http.directory of our export path. So we just need to define this add headers function. So I'll do that at the end. And it's going to add headers required for the HTML5 export to work with threads. And we can just say it's going to take a http.handler, and it's going to return a http.handler. So it'll return http.handle handler function, and this function will take, we can use VS Code to help us out. We'll just click this. It's going to take a writer and a request, and this is going to set the headers. So w.header.set cross origin opener policy will be same origin, and we'll set the cross origin embedder policy to require corp. So if you're wondering, this stuff comes from the Godot documentation. So yeah, this is just coming from this page where it's talking about exporting for the web, and it will say something about thread and extension support. Yeah, here we go. It says if thread support are enabled, we will require a secure context. So it requires these headers to be set. So that's where this is coming from. So then we'll just choose next.serve HTTP using the modified writer and response and request. So we can save our add headers function, and now we have no errors. So let me try running just locally again. So I'll press F5 from VS Code just on my Windows machine. So it says serving HTML5 export from my supplied export folder. So if I open up my web browser now, and because we are serving this route from our Go server, we are also using the same TLS certificates that we provisioned using the mkcert tool. So these are our self-signed certificates. So I can type https://. So we're using secure HTTP, and I can type my fake dev domain. So dev.radiusrumble.tbat.me, and I'll just need to use my port number of 8081. And if I visit that, I should get the client is being served to me. So this is how I'm able to serve my own game client from the same server that I'm running the server. And this version should be a little bit better performance because it's using threads. And we have a lot more freedom hosting it here as opposed to itch.io. So let's get this onto our server. So I'm going to use the scp command again. So I'll just make sure that my game server is not running first. So I will use so I'll just grab the process ID of whatever's running on port 8081. And I'll copy this process ID. I'll type sudo kill-94688. So now my game server is no longer running in the background. So now I'm free to update my server code and upload my game files. So I'll come back to my project directory /server, and I'll just move into my CMD folder. So this is on my local machine, and I need to copy main.go onto my server. So I'll do scp main.go, and I'm copying it to t@debian:/home t radius rumble server /cmd/main.go. So now if I check my main.go, I can see that I now have the updated code. So I've got this client path string in my config. So I've updated my config, I've copied the new main.go file across. I'll just move back into the server directory, and I'll need to recompile my Go code. So I'll type go build ld flags sw cmd/main.go, and then I can run my game again. And you can see here it says file not found at radius rumble data/export. So I've just got a little underscore here I need to get rid of in my environment variables. So I'll edit my env file, and I'll just get rid of this underscore. So that's just a typo. And let's try running the server again. This time I'll use sudo. So it says serving HTML5 export from this location. So now if I come to my actual registered domain, https radiusrumble.tbat.me:8081, this starts serving my client code and connects to the server. So now I can give this URL to anyone. And if you like, you can even serve your game over port 443 instead of 8081. And that will mean that you don't need to have this colon. So you can just give someone this URL and it just looks a little bit more legit. But if you're serving over a non-443 port, you can just give them this URL with the port number, and they should be able to enter that into their browser and connect to the game as well. So if you made it this far, you've finally deployed your server and your client to your own hosted server at home or on some sort of VPS. So if you've made it to the end of this video, that means that you've created an entire MMO from scratch and deployed it yourself to production. So hopefully you've learned as much as I have with this series. It's been a long journey and it hasn't been easy, but hopefully we've all learned something along the way. The possibilities from here are literally endless. You can modify this as a base, and you can take this any direction you want. It'll be really awesome to see what people do with this. If you have any questions, or if you get stuck at any point, please let me know on the Discord server. There's no shame in asking for help. And myself and other people who have followed the course are more than happy to give a helping hand. Finally, if this series has helped you out and you want to give something back, the best thing you can do is just click like on the video, subscribe, and join the Discord server to help us grow. So good luck on your game development journey, and I'll see you in the next one, whatever that may be.